Alright, it takes 27.3 days for the moon to orbit the Earth. Determine the following: the orbital radius of the moon, which is the r drawn here, and the orbital speed of the moon. Okay, so if we look at this, the moon orbits the Earth. We know that the gravitational force of the Earth changes the velocity vector so it can orbit in a circle. If we look at Newton's second law for the moon, we have AC is equal to the force of the Earth on the moon divided by the mass of the moon. Alright, since we are assuming it's a circular path, we have the orbital speed v squared divided by the radius of the circular path is equal to capital G times mass of the Earth times mass of the moon divided by the orbital radius squared divided by the mass of the moon. Alright, looking at this, we can divide out the masses of the moon, and we can rewrite this as V divided by the orbital radius is equal to GME over R squared. Okay, if I solve this for or simplify the radii here, I get V squared is equal to G mass of the Earth divided by the orbital radius. Oh wait, there's no square there. This will divide out with one of those. If I multiply both sides by R, okay, alright, the square, that goes away. Now if we look at this, we're only given the period, so this speed here is going to be 2 pi times the orbital radius divided by the time it takes for one complete circle of the Earth, which is 27.3 days. So if I square V to substitute this in over here, I get 4 pi squared R squared all over T squared. And since I have no room, I'm going to bring all this information up in the middle of the page here. So it's going to be 4 pi squared R squared divided by T squared is equal to G mass of the Earth divided by the orbital radius. They're looking for the orbital radius of the moon, and we know the period and we know the mass of the Earth. Okay, so if I just solve for R, I get R cubed is equal to G times ME, and if I multiply both by T squared, okay, I'm going to have T squared up top over here, okay, and then divide both sides by 4 pi squared. Okay, divide this whole thing by 4 pi squared, and then we can substitute numbers. Take the cubed root of this, or raise this to the 1/3 power, and we can solve for R. Well, if we convert the period to seconds, alright, 27.3 days would multiply by 24 hours per day and 3,600 hours, or 3,600 seconds for each hour, you would get 2.358 times 10 to the 6th seconds. Sorry, that's really sloppy there. Okay, if you then multiply by the mass of the Earth by G and divide by 4 pi squared, you should get 3.82 times 10 to the 8th meters. Okay, and that's the orbital radius of the moon. Alright, so to find the orbital speed of the moon, I can do one of two things. I can go over here and substitute the orbital radius in and the time, the 27.3 days in seconds, so 2.358 times 10 to the 6 seconds. Or I can come over here and take the square root of V, and I could get V is equal to the square root of G times mass of the Earth divided by the orbital radius we just calculated, and that would be equal. Alright, that would be equal to 1.0 1 times 10 to the third meters per second. Sorry about the little mix-up before, and there you have it.